systems of equations. You need to know what a systems of equations is. So the first question is, what is a system of equations? A systems of equations is more than one equation Remember, equations are lines, so I'm going to put line in brackets. So it's more than one equation or more than one line being considered at the same time. What that means? Our last unit was linear relations. We were graphing things. We were writing out equations for lines. But we were always only doing it with one line. This unit is going to have multiple lines. Mostly two. You could get three, I guess. That won't happen, I don't think. You could have four, you could have five, you could have an infinite number. We always just do two. But the idea is that there's more than one. If there's more than one, it's called a system of equations. What we're going to do this unit is we're going to solve systems of equations. To be able to solve a system of equations, you need to know what that even means. So question number 2 is, what is a solution to a system of equations? What does it mean to solve it? What it means is where the lines cross. So what we're going to be doing is we're going to be taking these equations or these lines, and we're going to be figuring out where they cross each other. The coordinates of which they have the same x and the same y, the same spot for both. What methods can we use to solve a system of equations? There's going to be 3. The first one is 6.1. It's called substitution. Tomorrow, we're going to learn another way to solve these systems or find where they cross each other. It's called elimination. The final way to solve these is going to be 6.3, graphing. 6.4 will be word problems. So that is 4 lessons. We are going to solve or find where lines cross each other 3 different ways. The first 2 are algebraic. The third way is with pictures, with your graphic calculators. That means you will need your graphic calculators for sure starting Thursday. You'll probably want it. You do not need to master all 3 methods of solving, because all 3 methods work for pretty much every question. But you do need to have a good understanding of all 3, and then maybe master 1 or 2 of them. So when I give you a question, you can just always use elimination if you really like elimination. But I might give you a question where you have to do substitution. So maybe 1 question on the whole test, you have to be able to do substitution. Maybe another question on the whole test, you have to be able to graph it. That makes sense? So you know all 3, you master 1 or 2. That makes a little more sense once we're done. The other thing is I teach these in least popular to most popular order. So if you don't like substitution today, you might love elimination tomorrow. If you don't like elimination either, you might love graphing. Most people usually find one and stick to it. I go from the least popular to the most popular, because if I teach you how to graph, and half of you think that's the best method ever, you just ignore me for the next 2 days. You're like, oh, I can just graph it. Answer. And if I teach you elimination before substitution, some of you are just like, well, just do elimination, and you just ignore me for substitution. So I teach you the one you usually like the least, then the second least, and then the most. All right, let's start things off. At the start of each lesson, 6.1, 6.2, 6.3, there will be step-by-step instructions on how to use that method. These are the step-by-step instructions on how to use substitution. I'm not going to read through them with you. What we will do is do a bunch of examples together, and then you can see what I'm talking about with these instructions. Let's do the first one. The first thing I do is I label one of these equations, equation 1, and I label one of these equations, equation 2. I'm going to keep equation 1 in red. I'm going to keep equation 2 in blue. When I do algebra, I'll try to do it in green so that you can kind of see where things are going. The first step is to pick whichever equation looks more basic, looks easier. In this case, they both kind of look the same, right? So like this question, x plus 4y equals 17, looks about the same level of difficulty as 2x minus y equals 7. If you had one of these equations with a bunch of fractions and decimals, that would look harder. And I wouldn't pick that one. For whatever reason, some people really stress out about number 1, choose the simpler equations. You can't be wrong. There's no right answer. Like, I'm going to pick equation 1 in this question. You could pick equation 2 and still get the same answer. So when I say choose an equation, I just always choose equation 1 unless one of them looks crazy. So don't stress about which equation you start with. When I pick equation 1, my goal is to isolate one of the variables. What that means is get one of the letters, one of the variables, x or y, and get it completely by itself on one side of the equal sign. It does not matter which one. I'm going to get x by itself. The way to get x by itself is to move the y to the other side of the equal sign. If I have x plus 4y and I want it to move to the other side, I do the opposite operation. So I subtract 4y from both sides. My next piece of advice for this unit is you're going to do a lot of algebra. When you do algebra, write down what you're doing. So do your algebra, and then rewrite out your equation every time. So I subtracted 4y from both sides. Now I rewrite out what I have. So x stays the same, equals 17 stays the same, minus 4y is now on the other side. So every time you do something, do it, then reorganize. You're going to see in a second, we're going to do a lot of algebra. That reorganizing every single time is important. Keep yourself in a nice pattern. All right, we have chosen an equation. We have isolated a variable. Now we do what they call substitution. The way this works is this x over here in equation 1. We want it to be the same as this x over here in equation 2. So if this x in equation 1 equals 17 minus 4y, then this x in equation 2 should also equal 17 minus 4y. So we take this and we substitute it into that. Instead of x, I'm going to put 17 minus 4y. And I'm going to use brackets. So this will be 2 bracket 17 minus 4y minus y equals 7. See the substitution I did? Awesome. The reason I did that is if you look at equation 2 now, you'll notice there's no x's in this equation. Anytime there's no x's in your life, it's a good thing. That's good. Right? Thanks, Jason. Appreciate it. There's no x's in there, which mean I could figure out what y equals. It's the only variable left over. To do that, you have to get y all by itself in equation 2. The first thing you need to do to get y by itself is expand. So if there's any multiplication that needs to happen, you do it. That 2 needs to multiply into the brackets, which I just inserted. That gives me 34 minus 8y minus y equals 7. So I multiply that 2 in to get those things into green. Everything in blue stayed the same. So the first step was any multiplication that needed to happen, any distribution. The second step is collect any like terms you might have. If you look, I have some like terms right here. That means those things can combine. My 34 is going to stay the way it is. 34. My negative 8y minus 1y would be minus 9y. Equals 7. Remember there's an invisible 1 in front of that other y, so negative 8 minus 1 would be negative 9y. Once I've multiplied everything together and I've combined my like terms, I now should have a basic linear equation, which I do. I have one letter all by itself, right, just these y's. Everything else is just numbers or constants. I need to try to get that y by itself. I'm just going to rewrite it out over here so I can see it organized. If I want to get that y by itself, it means I need to move everything else to the other side. You always start with moving additions or subtractions. So the first thing I need to try to move to the other side of the equal sign is I need to subtract this 34 to the other side. That'll give me negative 9y equals negative 26. See, I did something, I rewrite it all out. Notice that I write out the equal sign every single time. I write out the full equation, I don't cut corners. Alright, I almost have this y by itself. There's one last thing attached to it. I have negative 9y. If there's nothing in between a number and a letter, that means they're being multiplied. So what's the opposite of multiplying? Divide. So we divide both sides by negative 9. That gives me y equals 3. A lot of algebra, right? I didn't lie. I only lie when it benefits me. That wasn't a lie. A lot of algebra. And we're not done. So you just solved y equals 3. Think back to the very first slide, and I said, what is a solution to a system of equations? A solution is where two things cross each other. That means it should be a point, and every point has a y value, but it also has an x value. So you've only found the y value where these two equations cross each other. To find the x value is a lot easier. The reason being is you've already isolated x in equation 1. So what you do is you take your answer from equation 2, and you substitute that answer back into equation 1. So you took your answer from equation 2, you link it all the way back into equation 1, and you'll have x equals 17 minus 4 times 3. X is already all by itself in that equation. So if you want to figure out what x equals, you just put this in your calculator.
But sometimes you have to keep going.
In substitution, you'll never have to keep going. That's why I like substitution, because it makes the second number really easy to find. If you use elimination, then you do have more algebra to do sometimes. Sometimes. If I put that in my calculator, my answer is x equals 5. So the solution to this system of equations would be x equals 5, y equals 3. You can also write it as a point, because we are talking about where two things cross each other. It's a lot of algebra. The only way to get good at algebra is a lot of practice. The only way to get confident in it. Anybody have any questions about that one? We're going to do 3 more examples together. Think about it for a second. Okay. We'll try it again. So the question below, solve the following system of equations through substitution. I'm going to slide everything up. The first thing I do is I call one equation 1, one equation 2. It helps me stay organized. Also helps me discuss this stuff with you. So that I also color coordinated. It's mainly for your benefit to really try to see where things are. You choose an equation that looks easier. They both look the same to me. I think this one looks a little easier because it equals 0. That seems easy to me. It doesn't matter which one you choose. You can't be wrong. But let's all just choose equation. Inside of equation 1, you now have to isolate x or y. You have to get x or y by itself. See what it equals. It doesn't matter which one you choose. I'm going to choose to get x by itself. So if I want to get x by itself, it means I need to subtract 3y for both sides. That'll give me 4x equals negative 3y. I don't quite have x by itself yet. What do I have to do to get x completely by itself? Divide by 4. Awesome. Right? A number by the x means it's multiplying. You always do opposite operations to get something by itself. Divide by 4. When you divide by 4, you divide the coefficient by 4. So that makes my new equation. X equals negative 3 over 4 y. I've isolated one of my variables. Now I can substitute that into the other equation. So if this x equals negative 3 over 4y, then this x up here should also equal negative 3 over 4y. That's called substitution. So I take that and I substitute it over. I then write out what I have. I have 8 bracket negative 3 over 4y minus 9y equals 5. Whoa. If I could do that again, I would. Everybody sees the substitution I did? I don't know if I need extra space or not. Actually, I think I'll tell you where it was. Trying to make sure I have enough space so I can do all my work. Once you've done your substitution, if you did it properly, there should be no x's left in your equation. It should be all y's. It is all y's, right? That's good. Now I need to multiply and then add and subtract like terms. So multiplying is the first step. I have to multiply because there's brackets here. So that means this 8 needs to multiply into the coefficient. To do that, in my calculator, I go 8 times negative 3 divided by 4. That gives me an answer of negative 6. Minus 9y equals 5. So I did my first thing, I expanded. I distributed that 8 into the brackets. I then collect any like terms. Sometimes there's not any. In this case, there is still. I have negative 6y minus 9y. That can add together to be negative 15y equals 5. I almost have y by itself. What's the last thing I need to move to the other side? The negative 15, and I divide the negative 15 both sides. That gives me an answer of y equals negative 1 over 3. You put in your calculator at 0.33333333. Math, frac that. I prefer you to leave things as fractions unless they're terminating decimals. So if it had been 0.5, that's okay. If it's 0.75, that's okay. If it's 0.33333333, I change it to a fraction. Yeah, that's kind of my rule of thumb. That's half my answer. These two equations are the same when y equals negative 1/3, but we have no idea what x equals. How do I get what x equals? I take my answer and I substitute it back into equation 1. I take this value, 1 over 3, and I substitute it back into equation 1. That gives me x equals negative 3 over 4. Instead of y, I have negative 1 over 3. And I use brackets. To put that in your calculator, because you can now calculate this value, you need to tell your calculator that that's two fractions, and you do that by using brackets. Okay, so you would go bracket negative 3 divide by 4 bracket. That's telling my calculator this is a fraction. And then I go bracket negative 1 divided by 3 bracket. That's how I calculate. This is the other fraction I want to multiply by. If you do that, you should get the answer of x equals 1 over 4 or 0.25. Both answers would be acceptable because it's a terminating decimal. So the solution to this systems of equations is that x equals 0.25, y equals negative 1 over 3. I personally like substitution the best, so that's what I'll usually go to is when we do our word problems. You guys typically like elimination or graphing. That's usually the two that people lean towards. But some people really like substitution as well. It's heavy on the algebra, which is why people sometimes don't like it. It's a lot of moving things over. I'll also show you when it's more beneficial to use one method over the other. It won't make sense until you know the other methods. Right? That's a question that might be more beneficial to eliminate in the future. But I'll show you. You'll be able to recognize when it's better to use which method, hopefully. All right. One more example. This one is like a high-level one. So this would be probably the hardest substitution question we would give you. The steps are all the same. There's just more of them. Maybe that's the only thing that messes things up. So, what that sounds like? So, if you could do a question like this, like yourself, okay, because this is about as complex as it's going to get for you guys, especially on a test. Again, it's the same rules. It's just more. Like, you'll see what I mean. There's just more multiplication, more adding, subtracting. That's all it is. The first step is still to label one of them as 1 and one of them as 2. And then to choose one of the equations to initially isolate. I'm going to choose equation 1 to isolate a variable. I'm either going to get A by itself or B by itself. It doesn't matter which equation you pick. Okay? Like, don't forget that. You can pick either equation. I'm just choosing one arbitrarily. To be able to get one of those letters by itself, you first have to get rid of the bracket in that equation. So I have this set of brackets right here. I mean, I need to multiply the 5 in to all the coefficients. Then I can start moving things around to get the letter B by itself, which is what I'm going to aim for. So I multiply that 5 in. It gives me 10a minus 15. Everything else stays the same. Plus b equals stop. I then have to choose one of those letters to get by itself. You can't be wrong. Right? One of them is usually easier to get by itself. Why would B be easier to get by itself than A? There's no number attached to it. Right? There's no number in front of this B, which means I'm not going to have to divide later. There is a number attached to the A, which means it's going to be one more step. It also means I'm going to create a fraction at some point. I always try to avoid fractions. So the more you do this, the more you'll probably recognize there's easier things to move or get by themselves. Okay, I'm going to get B by itself. To get B by itself means you need to move all additions and subtractions to the other side of the equal sign. I have a minus 15. I'm going to move it first. You move it by doing the opposite operation. So instead of a minus 15, I add 15. The 10a is still there. The plus b is still there. Equals 20. Every time I do something algebraically, I show it, and then I rewrite my entire equation. It makes your life so much easier. Now that I'm at this stage, if I want to get the b by itself, what do I have to move? The 10a, it's a positive 10a that's being added, so that means I need to subtract 10a from both sides. That leaves me with b equals 20 is still 20 minus 10a. I can't combine those like terms because that one has a and the 20 doesn't. Right? So it's okay to just write it out as a string. Yeah.
Why wouldn't you just put minus b to the other side?
Because, yeah. We could have minus b, minus 5. It'd be the same thing. Make sure that you keep the negative on the b, because then you have to divide by negative 1, right, to make it positive. But that would work too. And what you guys are going to notice is that you can do these questions a lot of different ways. I just show you what I think is the easiest and most logical to me, but there's definitely more than one way. Right? So Callie just brought up a good point. What if you just moved the b to the other side and then got b by itself, but on the right side? That would work. And you get to the same level of b equals 20 minus 10a. You should get the exact same thing at some point. Now that I have one variable isolated, what do I want to do with that one variable? I want to move it from equation 1 into equation 2. When I do that substitution, everything else stays the same. So I have 6a minus 2 bracket. Instead of b, now I have bracket 20 minus 10a. I'm going to use square brackets. I want to look up just to see what that looks like. Because you do have a bracket, then a bracket, and then you start your numbers. Okay, I like to always substitute with brackets. The reason being is it reminds me to use coefficients to multiply any words. If I have two sets of brackets right next to each other, then that's how I write. I'm using a different shape of bracket just so it really sticks out to you. You don't have to use a different shape. Then you still have minus 4, curly bracket equals 0. All right, I did my substitution. If you look back at all the other examples, right after we substitute, we do any multiplication we need to. If you look at this thing, start from your inside bracket. So I have a set of square brackets. Is there a number right out front of the square brackets right here? It's just an invisible 1 right there. That thing would be to multiply in, but multiplying 1 in doesn't do anything. Essentially, those square brackets were doing nothing for us. If there had been a number in front of the b, then those square brackets would have actually mattered, right? Because then something would have had to multiply into the square brackets. But in this case, there was nothing there. So I can get rid of the square brackets. And be left with just my round brackets. Now I do my next level of multiplication. So if there's something that needs to be multiplied into the round bracket, a 2, and that 2 is negative. Right? Make sure you bring in a negative 2. So that thing multiplies to all the coefficients inside the bracket. My 6a remains out front. I then have negative 40 plus 10a. Oh, sorry, plus 28. And then plus 8 equals, I've done all my multiplication. Now I want to collect any like terms that are on the same side as the equal sign as each other. So on the left side of the equal sign, I can combine my a's. I can also combine my constants. That'll give me 26a minus 32 equals 20. Again, I'm going to repeat myself for like 100th time. Every time I do something, I rewrite it all out. The whole equation. It might seem tedious. Try doing it without it, and you'll realize how hard it is. Right? Every step, I rewrite everything. Including the equal sign, including the other side, even if I didn't change anything. All right, I multiplied, I distributed, I added, I subtracted, everything's combined. Now, I can start to get my only letter by itself. I have a over here. To get it by itself, I need to move that 32 by adding it to both sides. That'll give me 26a equals 52. My last thing I'll need to get rid of is the 26. To get rid of 26, you divide by 26. That gives you a equals 2. All that math and a equals 2. Getting a equals 2 is fantastic. What do I do with that information? Perfect, yes. I take my answer, a equals 2, and I substitute it back into the first equation. And, just for fun, if I'm marking a question and it's a written response question, I mark you based on, did you get the value for a right? And if you didn't, but you calculated b based on your mistake, you can still get half the marks. Okay, so it's 1 mark for getting a, 1 mark for getting b, but b has to be the right value for whatever you said a was. So you could be wrong here, but right here, so get half a mark. And that's kind of good news. So I substitute that over there, it gives me b equals 20 minus 10. Instead of a, I have 2. We throw this whole thing in our calculator. You end up with b equals 0. So your solution would be b equals 0, a equals 2. What this means is if you took the value of a equals 2 and b equals 0 and you put them into the equation, it would work for both equations. Both sides would equal each other still. If you imagine those as x and y instead of a and b, that means these two lines cross each other at 2, 0. Right? If they were x and y. Kind of another way to think about it. That's about as hard as it can possibly get. That's a challenging question. We'll do one last one together. Okay? We're going to scrap this first question. The reason being is we haven't done graphing yet. I reordered the lessons and then screwed up and didn't delete that part of this lesson out. So I'm just going to scroll this up. We're also going to scratch out this beautiful word that says graphing. We're going to say substitution. First step, name one of them 1, and one of them 2. The reason this should be a pretty good substitution question is if I said, pick an equation that looks easy, let's pick number 1, and I said, get one of the letters by itself. One of the letters is already by itself. That's why this would be a good question for substitution. That first part where we did all that isolating, it's already done for you. They've already given you y by itself. That means my first step actually becomes substitute that in for y. You can jump straight to the substitution part of the question. If this y equals negative 2x plus 9, this y should equal negative 2x plus 9. I'll write it in brackets just for good habit. It makes no difference. If you substitute correctly, there should be no y's left in your entire question. There isn't. It's all x's. Now your goal is to figure what x equals. You can't do any multiplication here. There's nothing to distribute. There's nothing else other than brackets. You also can't add any like terms because they're on opposite sides of the equal sign from each other. So what you need to do is move all your x's to one side of the equal sign and all your constants to the other. We're going to move all of our x's first. So I want to move all my x's to the right side, so I'm going to add 2x to both sides. You could also go the other direction and move all your x's to the left and get the same ends. That leaves you with 9 equals 5x minus 7. I want to get all the x's by themselves. I have to get them all on the same side together. I've done that. Now I can start doing what I regularly would do. I need to move anything away from the x's, starting with additions and subtractions. So I have a negative 7. I need to add 7 to both sides. That gives me 16 equals 5x. Then I need to get rid of the 5. How can I get rid of that 5? Divide both sides by 5. That gives me, if you put in your calculator, it's 3.2, terminating decimal, so I'll do it. It gives me 3.2 equals x. You could leave it as 16 over 5 if you prefer fractions. What do I do with that? Bring it back up into equation 1. Right? So I take this thing, 3.2, and I substitute into that thing. So my new equation over there is y equals negative 2. Apologies, I was missing bracket 3.2 plus. Right? Yep. We put that whole thing in our calculator, and you should get y equals 2.8. Has anyone done it? 2.6. 2.6. Awesome. So the solution to this system of equations is y equals 2.6 and x equals 3.2. I just want to say something about this calculating part. You only put this part in your calculator. Okay, you don't put anything else in.